Hello and welcome everybody. This video is part of the lecture series of this course, Electronics and Microprocessors for Mechanical Engineers. My name is Dr. Sami Salama Hussein Hajjaj, and I'm going to be instructor in this course. In an earlier video, I discussed the contents of this course in its entirety. Make sure you check out that video. I will leave a link to that video in the description area. Now we are part of, we're actually, this video is actually a continuation of a previous video. In that previous video, I discussed already a refresher on C++, and I conducted an extensive refresher on C++, but I felt that there was one section where it needs a little bit more attention. So specifically, we talked about all of this stuff in that previous video. You might want to check it out. The theory of C++, setup and installation. We talked about variables, user input, operations, conditionals, loop functions, everything. But there was one specific type of conditionals that I feel that it needs more attention. So we talked about the if statement, the if else statement. We talked about switch case, and we saw examples of the switch case. And then now we briefly mentioned the exceptions, or the try and catch exception, but I feel that this needs more attention. Once again, we talked about this earlier when we talked about the try and except scenario. Then you actually have a bunch of lines of code, and you worried about the output of this scenario. You might worry that this could cause a problem, could actually crash your program. For example, you ask the user to input a number, but then the user does not input a number, inputs a word, and then in that case, the program will crash. And this is the last thing you want to happen into your program. A program that crashes is definitely not good. And if you're a developer and you sell a product that crashes, then obviously you will be fired. If not alone, you will lose your business. So that is the last thing you want to do. But then again, on the other hand, you don't want the program to crash. And what you want to do is that then use the try and catch block. The way that the try and catch block, or the official name is exceptions, is that where you put the code that you were worried about here, and basically you want to try it. And then if the program if the program goes well and does not actually cause any error, in other words, you tell the user to input a number and the user does input a number, then we are all good to go. So this will run and this will essentially be ignored. But then if not, let's say if the user is a little bit cheeky and then they actually do not follow the rules and they input the wrong information and then causing the program to crash, the program, because you use the try and catch construct, the program will not crash. Instead, is going to catch that error, is going to catch that problem, and then is going to actually capture it and inform the user. How does that work? Well, you can actually then write here a little bit of code. You can actually write a short message that explains the error and then perhaps include some instructions into what to do. For example, again, if the user typed a number, the user is required to type a number, but the user did not type a number, then you can write error warning. You are supposed to type a number and not a text, and then the user will follow the instructions, and then the program will run fine. Does that sound familiar? Did you see something like this before? And the answer is yes. Actually, if I just come and do this now and then just run this programming now, the program did not crash. Instead, I got an error message. This is exactly how the error message mechanism works. The way that the error mechanism works is actually through something very similar to try and catch. The way that the compiler really works is that it's going to try your block of code, but instead of just crashing out, it's going to check and try to see where the source of the error, and then it's going to tell you or send you a message that is going to tell you how the program, the cause or the possible source of the error. And this is how error messaging or error messages mechanism work, and this is how the try and catch mechanism works. Now, as a solid example of the exceptions or the try-catch statement in C++, let's take a look at a solid example. So this is actually a simple program that actually does a very simple job. So I'll just remove this math thing for now. And this is very similar to the Hello World program. All it does, and this is something we've done before. We initiate a variable, then we ask the user to input something, and then we assign that value to it. We've done this already in a previous video when we worked with capturing user input. And then we take that input and then we simply display it out again. That's all we're going to do. So let's go ahead and run this simple program. Success, and here we go. Enter a value. Okay, here's a value. And great, the value is right there. Okay, let's try this again. So enter, why is this indent? Oh, there's a space here. I think by mistake I put it there. So let's do this. Okay, so compile again, and then input, and then enter a value, anything, right? So I'm gonna put some gibberish text, and then it's gonna give me again nothing. That actually something else. Because I declared the variable as an integer, but when I typed a text, so the system will not recognize that input. Okay, so this is essentially a general application. Now, let's just say now that you don't have this general input a value or enter a value. You want something more elaborate. So let's take a look at what is more elaborate mean. So let's just say that instead of input a value, you are required to enter something specific. Enter an integer that is within the predefined limit. And this is the predefined limit. In other words, that this number has to be less than or equal to 8. As you can see, this is a very strict requirement now. And why we need it that way, that's not the point. The point is that this is the requirement. So the requirement number one is we need an integer. And requirement number two, it has to be less than or equal to 8, right? So less than or equal to 8. So anything, any integer that is less than or equal to 8 will be accepted. But anything above that, so what are the possible failures? If the integer, let's say, is greater than 8, it will fail. Or if it's not an integer, let's say it's a float. Or if it's a text. So in any one of these conditions, fail, then the input should not proceed to this step right here. So we actually introduced this before, and we call this issue validation, or we call this validation. We said in a previous video that you might want to validate the user input before you actually proceed with that input. And in this video, we are actually going, or actually in this section right now, we're actually going to do exactly that. So how does this work? So we want to do validation. So let's just actually now figure out the main construct of the validation program. So the validation actually looks like this. So let's just begin to dissect this one first. So first of all, it's going to be in a while loop. So let's just control X. So why is it going to be a while loop? Because what you're going to do is that you can actually take this prompt that you see here, which is, the one that you're actually going to capture from the user input. And you know what? Let's keep this one here, and then let's just drop this guy for now. And this is going to be our validation. So what I'm going to do, I'm going to take this prompt, I'm going to put it inside the while loop. Okay? And then what's the general strategy is that the general strategy is I'm going to actually ask the user to input the number according to this rule. And then basically, if the user follows instructions, right? Instructions, then exit the loop. Else, if not, let's say if that's not the situation, right, then if not the case, then inform the user. Sorry, first of all, reject the input, inform the user, or the user, right, and then restart, or reprompt. Prompt is this part right here when you actually tell the user to input something. What do you mean? How are you going to reprompt? Basically, you're going to come back to the loop again and you're going to start all over again. So once again, what is going to happen? So if the user input the follow the instruction, exit the loop. Now, if exit the loop, then what happens? If we exited the loop, that means we are done with the validation, and then we can now use the value. But let's say if the user does not follow the instructions, let's say does something against the rules, like here. So if the user does not follow the instructions, then in this case, reject the input. Reject means we cannot use it. And then inform the user, reject the input and inform the user. I'm going to make it one step right here, inform the user, and then reprompt. How do you reprompt? Basically, come back to the loop and then go back here and start again. This right here essentially is a shortcut. Essentially, this is a while true loop. And while true essentially is a loop that is going to run forever and ever and ever until you tell it to stop, essentially. And in fact, if I run this program right now, then you're going to see this prompt running forever, because that's exactly what the while true will do. In fact, let's go ahead and, for fun, let's go ahead and do this. So compile, success, and boom. And you can see that it's actually running, and it's going to keep on running until the end of days, or until I simply stop the program. So that's why this is the beginning, that we can actually simply ask the guy to tell us the value, and then we're going to check it. And then we can actually test the value. Now, the instructions are clear. It has to be an integer, and it has to be within the limit. Okay, so what are the possibilities other than integer? So the first thing, we have to conduct actually a few tests. So test number one, we'll have to check if the user inputted or entered, entered uh, a number, right? So it's possible that the user did not input a number at all. It could be a text, right? So it could be a text or, symbol or something like that. And that's the first test, okay? Could be essentially not a number, right? And then the next test after that, we want to test and check, okay, maybe the user did input a number, but maybe that number is not an integer. So check if the user inputted or entered an integer or a float. You know what I mean? Or, it could be a float, could be a double, or basically anything with a fraction, right? So essentially, it could be a float, could be a double, as long as it has a fraction or a decimal, right? And then after that, okay, let's say that that test was also successful. Then in this case, you want to check and see, okay, so after the first test, we're going to know for sure that it's definitely a number, okay, because we tested it. Because if it failed, we're going to, gonna reject and prompt the user and start all over again. So if this test failed, we're not going to come to these tests. It's just going to immediately check this condition. If that condition failed, then everything else will be ignored, and we're going to start all over again, and then going to reprompt the user. So again, so how do we do that? We're going to check that if let's say if okay, if not okay, then again this will happen, right? So we're going to actually say, going to copy this, we're going to put it here, reject and inform the user. Okay, then if this survived, or if this first test survived, then it's definitely a number. Then after that, we're going to check whether that number was an integer or a double. So we're going to check again if that's the case. If not okay means it's not an integer, it's a double, then again, we're going to reject and inform the user, right? And then finally, if it's an integer, but if the integer, there's one more test, by the way. Okay, at this point, it's an integer. Okay, that's great. So check if the integer, if the integer is within, or within the limits. This is the last test. So you see, right here is the final test. Okay, it could be an integer, okay, but it's maybe greater than 8, right? So it's still going to fail. So this is the last test. So if it's not okay, then reject and inform the user. And then after that, basically after that, if all of these three tests survived, then if all of these cases survived, then in this case, we are done. So in this case, you can say else. Then if that's the case, that means the user did actually follow the rules. So then in this case, exit the loop, and then we are good to go. We are happy. We can actually now use the value. Now, of course, we could have done this with if statement, but I'm going to use this example right here to use the try and catch block, because sometimes you could use an if statement to check a condition, but it's difficult to use an if statement to check an error. The best way to do this is to check using the try and catch block. So I'm going to come back here again, and I've already done this part of the code, so I'm going to actually copy. What we're going to do actually is this structure right here. So actually it's going to be, well, you know what, we can just do it here. So I'm going to simply say try, and then just do it, try, and then open the bracket, and then all of that is going to be tried here. So basically, all of our tests and experiments, right, was going to be inside this try block, okay? And if the try block worked, then if all of these tests survive, then basically, in this case, we're going to arrive at this line of the code, which means that the user, basically, if all of these tests succeed, so we're going to say success, the user followed the instructions, and then in this case, exit the loop. So that's basically how we're going to do this. Otherwise, if the user did not actually follow the instruction, then we're going to use a catch block. And this is how you actually write a catch block. Now, the way that the catch block actually, you must actually give it a number here. You must give it a variable, because sometimes you will have specific catches for specific errors. But if you want to do a general catch, then you just simply put the 3 dots like this, and that will be sufficient. So basically what's going to happen if any of the tests above here failed, right? Then in this case, this block of code will run. And what is this block of code will do is simply is going to say error, try again. So I'm going to take this prompt, I'm going to put it actually inside the try. Wait a minute. No, that is going to be actually that will remain here. So this prompt will always remain outside of the try block, but it's going to be in the while loop. So let's take a closer look of what's going on. So I'm going to close this try and catch block. So again, so this is now the structure of the validation code. We're going to basically put it all in a while loop. We're going to then give the instructions in the beginning, and then we're going to allow the user the chance to key in or to input the values. And then we're going to test the input that the user inputted. Now, if that value or if that input is successful, then we're going to succeed here and we're going to exit the whole thing. Meaning, if it's all good, then the try block will be executed and we're not even going to see the catch block. But if there's a problem in any of these three tests, then we're going to fail. And in this case, the try block is going to fail. And in this case, we're going to come and execute this part of the command. Is that right? So these are the three. This is now the general loop. Now, if let's say if we succeeded and this worked, then we're going to exit this while loop. And then we're going to come here and the value will be successful. Otherwise, it's going to be failed. And now, by the way, if we failed, by the way, let's just go back here. Let's just say the user did not follow the rule and we come here. Okay, we're going to inform the user, hey, user, you did not follow the rules. But after we finish this catch block, we are still inside the while loop. I mean, even after you finish this catch block, which is, inform the user that we have a problem, well, you are still within the while loop. So we're going to have to start all over again until the user follows and until the user arrives here. By the way, and this is very easy to exit the loop. We're just going to simply write break, which is exactly the same break that we saw earlier when we worked with switch case. If you remember, in the switch case, we had what is called the break. This is exactly the same command, a break. The break command is not unique to the switch statement. In fact, you can use it anywhere you want in the program to exit any block. You can use it to exit a function, you can use it to exit an if statement, you can use it to exit any kind of block if you want. Basically, it means simply exit this block of command and get up one level, something like that. So since we are inside a try block, or since we are here inside a while loop, when you click on break, it's not going to exit just the try block, it's going to exit the whole while loop, and then it's going to exit. So, but once again, the way we exit the loop is simply by using the break command, which is right here. Okay, so right now, if I run the code, this will run only once because there is an exit, so the loop will only going to run just once. So let's go ahead and try it. We have an error input. I was not initialized in this function. Input was declared up here, so what's the big deal? Grade the value is. Did I use or forget a block? No. I declared the value. Oh, I did not change the value, or I did not update the value. Yeah, the value was declared, but it was not used. So, I'll just ignore that for a minute and let's just run it. Oh, wait, this is still the previous version of the program. This is still a warning, but the compilation is successful. The compiler is telling me that I declared the variable, but I never changed it. You know what I mean? So this input is going to come up with nothing. That's fine, and the value is 0, but because I'm not really doing anything. I'm just establishing how the break works. If I remove this command here, if I just comment it out for a minute, we're going to get back to that infinite program. You know what I mean? So this is basically to establish or to demonstrate how the block or how the break thing works. Okay, we broke it only once. Okay, so now what's going to happen? Now, basically, what's going to happen is that we're going to actually now going to use this. Now, okay, so what about the errors or the problems? So what's going to happen is that if this test fails, it's going to cause an error. And if it's going to cause an error, everything after it is going to be ignored. So even the break command is going to be ignored. So if this error happens here, we are straight away going to jump to the catch. That's what the purpose of try and catch. So once again, I'm going to say this. So let's say if we tried this line of code, it's a couple of lines of code, and they caused an error, right? Then if that error happens, the rest of the lines will be stopped, and straight away we're going to jump to the catch, and that result in the problem here. Okay, so let's do the first test. The first test actually, I've done this actually code before again, so I'm gonna actually copy this code from somewhere. Actually, I wrote it down here, but just gonna because I don't want to write the whole code in one shot. So what I'm gonna do right now, oh yeah, before we get to that, so what I'm gonna do right now, I'm gonna actually come up here and change this slightly. I'm gonna call this guy input integer, right? Because I want this to be an integer. And then I'm going to actually declare a couple of more variable or more inputs. So I'm going to call this guy raw, and this one I'm going to call it as, number for number, yeah. And the raw one will be a string, and this one will be a float. If you want to call this double, also can, not a problem. But basically, what I'm gonna do actually, if you think about it, when you ask a user to input, there are only three possibilities really. It's either a string or a float or an integer. Nothing, right? You cannot type a Boolean, okay? If you want to type a Boolean, you just type 1 and 0, which is once again a number or a string, right? So it's going to be one of these three possibilities. So I'm going to actually declare or initiate three variables, a string for an input raw, and then input num, and input integer. And of course, this is what we want in the end. So in the end, I'm going to come down here, I'm going to type input integer. This is exactly what we want in the end. And this is still a warning because I haven't used the value. So we're going to ignore the warning for a minute. Okay, so what are you going to do after that? So what I'm going to do in the test one, how are you actually going to check whether how are you going to do this first test, which is how you're going to check whether the value is a string or a number. So in this case, what we're going to do, we're going to actually, first of all, I'm going to assume that the user typed a string. So essentially, by doing cn to input raw, basically I'm making an assumption that the user typed a string. So assume user typed a string. Even if, let's say, you typed a number, let's say 7 or 54.5, we're going to take that and we're going to put it as if it was a string. Don't worry, I'm going to convert later on. For now, this is what we're going to do. Next, after that, what we're going to do, we can actually use something called casting. And this is something I may have not discussed before in C++, but consider this is the first time we discuss it. So what I'm going to do right now, basically, I'm going to do this. I'm going to actually, first of all, I'm going to capture whatever the user input. I'm going to consider it as a string. So if the user inputted 5, John, or any kind of gibberish string or symbols or floats or numbers, it's okay. I'm going to capture it as if it was a string. And then what I'm going to do is I'm going to actually convert it using, well, not convert it, this is called casting. And what I'm going to do is that I'm going to convert from a string to a float. This is what STOF stands for, string to float. And by the way, there is also STOI, which is an integer, but I'm going to do that. I'm not going to do that right now. I'm going to use STOF. And STOF or STOF simply means that take this value, whatever it is, and convert it into a float. So for example, if the user typed this 44.5, right, which is a string, by the way, then STOF is going to convert it into 433.44, which is essentially a number, which is basically a float. By the way, if you used STOI right here, then this guy, if the user typed this, then the value will be converted into an integer. It's going to ignore the decimals. But for now, we're going to work with the float version. So by the way, this is going to be the version. Now, by the way, this STOF is a C++ 11 feature, I think. So it's available already without any extra libraries. Okay. All right. So well, then what? Well, after that, if it's all good, if it works, then this command. So, but before, what if the user typed this? Obviously, this is not a number. So obviously, this will not work. So this is now how you can capture the event when the user actually did not enter a number. So if the user actually typed something like this, obviously we cannot convert into a number, right? So that is why if user typed, or if the user did not input or enter a number, this will cause an error. This will cause an error. And that is if you remember, this is the exact purpose of the try block. By the way, I'm not putting it inside the try block. Sorry, my apologies. So I'm going to actually do all of this here, actually. This is where you're supposed to be doing this. Remember, the purpose of the try block is to check if there is an error, right? Now, if I actually run this command and if the user typed a number, it will work. But if the user did not type a number, let's say typed a text, then this will cause an error. But the program will not crash because once again, we are inside the try block. And instead, what's going to happen is that because this is an error, everything else after that, including the breakdown there, right, is not going to happen. It's going to be ignored. We're going to jump straight away to catch. And that will result in this block of command running. And then the value is going to tell you error, try again, and then after the catch ends, and we're still in the loop, and then we're going to come back again to this prompt right here. So let's take a look and see how that looks like. So compile, see if it's successful or not. Yep, successful. And once again, it's giving me the same problem that input is not defined. Input int. Warning, input int will be uninitialized in this function. Don't worry about it. It's just a warning. And build. Okay, and then run this program. So input a number that is less than 8. So I'm going to begin by inputting a number. So 55.5. Great. The value, the value is 13. Okay, something's going on in the program. It's definitely not 13, so I'm not sure what happened here. So obviously it's supposed to capture the number. So st to float is the number. Oh yeah, because input int, the one that is actually here. So instead, I'm going to do temporarily. I'm going to put number. Okay. So basically, this is the variable that we have right here. Okay, so let's try to compile. Again, it's telling me that this variable was not used, which is input right here. It was not used. We can ignore it, but I can do this also. So compile. Okay, compile. And before we execute, let's once again take a look at the code. So once again, I'm asking the user to input an integer, and then I'm going to take this input, I'm going to put it as a string. Then I'm going to take the string and I'm going to convert it into a float. If the user typed a number, it will work. And in this case, the value of input number will be updated to the number that the user inputted. And then we're going to come here and print it out. That's what's going to happen. Now, if the user did not type a number, let's say text or something like that, then this will cause an error. And because we are inside a try block, then this actually is going to jump here to the catch part, and then it's going to tell me this message, and then we're going to try again here. So let's take a look. So compile. Yeah, compile success, and then execute. So input an integer. I'm going to begin by typing 55.55 and grade the value as 55.5. And the program ends because you followed the instructions. Okay, let's try this again. So I'm going to write gibberish here, which is not a number. So obviously error, try again, but then we are still in the program. Enter an integer that is within the limits. So again, if I try another gibberish, it will still not work, and I can keep doing this forever and ever. It will not let me go until I type a number, and then finally the program responded. So this is the essence of validation. So as you can see here, we did a first step of validation only by using the try block, and we did not use an if state. But then again, this test right here only checks if the input was a number. We still have to check whether it's a float or an integer. Now there are several ways to, and this is basically the second test, which is right here. Now there are several ways to check whether the number is a float or an integer. The easiest of all is to check. Now let's see if I typed. Let's say if I typed a number, let's say 7, 4 or 4.0. Actually, these two are both integers. I know that there is a decimal here, but this is no fraction, no values. So these are actually, this is essentially a zero, a fraction. So therefore, this is an integer or a whole number. So that is how I'm going to actually test if the user inputted a fraction or an integer or not. So what I'm going to do, I'm going to wait for the user to type a number, and then I'm going to check this value right here, this fraction. And if this fraction is greater than 0, or at least it's not equal to 0, then obviously it's a float. So as you can see, this number right here is not equal to 0, right? So it's definitely not an integer, definitely a float. So that's exactly how I'm going to do it. So how do you actually do this? Well, I'm going to actually do a little bit of magic here. So basically what I'm going to check is I'm going to do what is called round down. Round down, or in some languages called floor, right? Essentially what it means is takes this number and is going to round it down to the nearest integer. So the result of this is going to equal to basically just 4.0, right? So then if I take this number, the original number, and I minus it from this number, I'm going to get only the decimal component by itself, like this. So that's essentially it. Now there are many other ways of finding the expression. You can use several other ways of finding the decimal section on its own. You can apply any technique you like, but I'm just going to use this one because I'm just happy with it. So what I'm going to do right now, I'm going to actually create a temporary variable right here, and I'm going to call it test. Simply going to call it test. And this is the input number. And if you remember, input number was the number that we captured from here. And if you recall, at this stage, we have confirmed that this is definitely a number, okay? Because if this actually failed, then we're going to exit all of this, and we're going to come straight away to the catch block. But if this worked, then we are now here. So what I'm going to do right now, I'm going to actually use input num minus floor input num. And floor is a advanced mathematical operation, so we need to include math. So include C math. So C math, and that will be all that we need to do. So that's essentially the program. So what is going on here? Basically, think of it like this way. So basically, if let's say if the number was 4 point something like that, so floor of this number is going to be essentially 4.0, right? So that's what the number is. So if I actually take these two numbers and I minus them from each other like this, from this guy right here, so the result is that I'm going to end up with just the decimal value. And this is basically what test is. Then this value right here, the 4 point something, or the fraction section by itself, is going to be allocated or assigned to the value of test. So this is basically the quick test that I'm doing here, or the quick calculation that I'm doing here, in order to just quickly calculate or find out the fraction. Then after that, I'm going to use a simple if statement to check if this value is actually equal to 0 or not, or at least if it's not equal to 0. So I'm going to actually take an if statement. So I'm going to essentially say if basically if this is the condition, bracket, and a bracket. So this is essentially how you write an if statement in C++. And then what I'm going to do then, this is the test. So if test is, if it's not equal to 0, how do you write not equal to 0? Well, actually, we did talk about operators before. So this is how you write not equal to 0.0. Now, because it's a float, I'm going to put a decimal here, so that's why it's a good idea. But if you forgot and you put a 0 like this, that will still work. So basically now, if it's not a decimal, obviously, sorry, if the value right here is not a 0, as you can see, something like this, so obviously the number is a float and not an integer. Is that right? And in this case, this is actually a failure. Now, what do you want right now? You want to have an error here. You want an error the same way we have it here. You could always do something like this if you want to cause an error, but there is actually a shortcut from C++. You could just simply do this, throw, and then we're going to throw a value. Just going to put simply, we're going to throw the value itself. It doesn't really matter what you throw, but you have to throw something. So I'm going to throw a test. So I'm going to put here and throw, that's it. Now, what is actually going on here? This line right here, it's simply what it says. This is essentially is a fake error. So what is going on here is that basically what's going on, what you're doing here, if this is true, meaning if the number that we have calculated is not 0, then the number is a float. Obviously, I don't want that. I want an integer. So if that's the case, throw an error. In other words, purposely cause an error. And when you throw something, you need to catch it. So where are you going to catch it? Right here again. So this is how the throw keyword actually works, and it usually comes along with the try and catch. Over here, we did not throw anything because we already have a situation where we're going to have a real error. Okay, but here we don't have an actual situation where we're going to cause any real error, so I'm going to cause an error by simply throwing an error at the compiler. So when this actually line executes, that this is exactly the same effect as this line over here. In other words, that this is an error. And when this actually happens, once again, every line after that is going to be ignored, and we're going to come again back to here. So now we're ready. Let's test this second condition. So compile and then run again. So now remember, now we have two tests, if it's a string and if it's a float, and both conditions should fail. So this one we tried before, it fails. So if I actually put, now we come and put a decimal right here, and again that fails. And let's try, by the way, if I try with a 0 like this will work because this is considered a whole number. So again, if I try another integer or another float, anything you want really. Let's try a negative, by the way. So then, and then put a random number here, and then put a text, put a random number, and again it's going to fail. And this will only work if you put an integer or a whole number. So again, now this second test actually worked, which is check if the number is a float or an integer. Okay, so now we still have one more test. If you look at the code just now, I put an integer that is greater than 8, and that integer actually worked. We don't want it to happen. We want again to test if the value was within the limit. And this is the easiest of all. We just put a simple if statement just like this one, but then we check the value and then we move on. And now before we actually do that, so this is now the test number 3. Check if the value within the limit. Okay, so what we're going to do that? Well, first of all, at this point, you have to remember, if we have reached this point successfully, if we did not throw an error, in other words, if this was not true, then in this case, test value will equal to 0. And if test value is equal to 0, that means we can arrive successfully or safely at this number. In other words, we will know that the user have indeed inputted an integer. So in this case, I'm going to come now and do this. Integer is going to equal to whatever number the user inputted. So I'm going to put it here, and let's recap what's going on. So first of all, the user inputted something, and so I'm going to capture that, and I'm going to put it as a string for now, because input raw was a string. Okay, let me activate this guy also. Okay, so then we're going to check if it's a number or not. If it's a failure, let's say if the user did input a text, then all of this is going to fail, and we're going to come to this catch block over here. Okay, now let's say the user did not input a string and it was text and inputted actually a number. So we're going to come here now and check if that number is a float or an integer. If it's actually a float, then we're going to purposely throw an error. Then we're going to crash the rest of the block, and we're going to come here again to this out, right? But then if it wasn't a float, and if indeed the user did type an integer, then we're going to basically confirm it. So we're going to now initiate input integer. We're going to set it equal to whatever the user inputted. Because if we arrived at this point, then we know for sure that the user did in fact input an integer. Now the only thing we have to check now is that if this value is within our limit, and that is the easiest of all. All we need to do is just another if statement. So I'm going to come here now. I'm going to do this. A little bit of organization. So now I'm going to check, and let's just throw this again. And basically, I'm going to check if the input value right here. Okay, copy. And if the input value, what's the condition? Actually, I already have the condition written for you right here. It has to be less than or equal to 8. So what's the opposite of that? Well, if the input wasn't less than or equal to 8, how do you fix it out? Well, the obvious answer is greater than 8, right? So if the input was greater than 8, then we can say now the integer is not within limit. What does that mean? It's essentially greater than 8. Now, of course, if you decided if you decided that right now the limit is hard coded right here, but if you want to make this limit user defined, then all you really have to change is to put the limit, the variable name right here. But then if it wasn't variable, if it wasn't user defined and you hard coded right here, then just put the number this way. Okay, so less than or greater than 8, not 9. So greater than 8. So if this is but obviously we don't want that. We want the integer to be less than or equal to 8. So obviously if it's greater than 8, so this will fail again. So how do you make something fail? Well, again, you throw another error. And then again, we throw another value, and we're not going to throw test again. We're going to throw the value, this guy right here. It doesn't really matter what you throw as long as you throw something. If you cannot throw a blank like this. You cannot do that. I'm not sure if you can do this also, but then it's a good idea to simply throw something. I'm going to check it out after this. But anyway, so let's say that this actually worked. In fact, the user did input a number that is greater than 8. If that's the case, that is going to cause an error. Then this will fail, and we're going to come back here again, and the user will have to input. But let's say the user actually did input a number that is less than 8. And in other words, this did not work. And in this case, we can say that the test tree is also successful. And in this case, we finally arrived here, and then we can exit the loop. And exit the loop, basically, we actually finish this loop, and now we come back to the end of the program where we basically capture the value, and then we display the output. Okay? So let's actually try this again, success, again, and execute. And now let's check out the situation. Text gibberish, fail. Float with numbers, fail. An integer greater than 8, fail. You can try whatever you want, it's not going to happen. Until you put an integer that is less than 8, and in this case, it will work. Great, the value is 5, and only then it will work. So this now is an example of validation, and also an example of using the try and catch block. And I hope this was a good demonstration of the try and catch block, as well as a good demonstration of the validation thing. So with this, I hope we captured the concept of exceptions, the try and catch conditional, as well as the concept of throw, and we also worked on validation. So I hope this covers this area. And with this, I feel that we have covered enough material for C++, and now we are ready for the next video when we talk about Python and we do a refresher on Python. So until the next video, thank you and take care.